The Exploratorium acknowledges that the total solar eclipse production we are bringing to you today is taking place on the unceded ancestral homelands of many indigenous groups, including the Kickapoo, Coahuiltecan, Jumanos, Comanche, Lipan Apache, and Mescalero Apache peoples. They are the original stewards of this region of Texas and Mexico. As guests, we wish to pay our respects by acknowledging their territories, their ancestors, and descendants.
Welcome, welcome, welcome to our live broadcast on the Day of Black Sun. We are here in Junction, Texas at the Texas Tech University Center at Junction. Today is going to be fantastic. This beautiful and unique campus is home of the nationally acclaimed Texas Tech Outdoor Learning Center and the Llano River Field Station. My name is Desiree Whitmore. I am the physicist and educator at Exploratorium, and I'm so happy to be here.
Hi there, I'm Julie Yu. I'm a principal scientist at the Exploratorium, and today we are going to experience a total solar eclipse. In fact, if we take a look at our telescope images right now, you can see an image of the sun, and it looks really flamey. Those are actually clouds blowing across the sun. It is windy here in Junction and sunny. So today that moon's gonna block the sun, casting a shadow here on Earth. Today, the shadow of the moon is sweeping across parts of North America at over 1,000 miles per hour. Millions of people from around the world have converged within a 115-mile wide path arching from Mexico to Texas to Maine to witness this rare and spectacular celestial event. The last total solar eclipse that swept across the United States occurred on August 21st, 2017. It's predicted that over 215 million people watched this eclipse online or in person. Perhaps you were one of them. And only 6 months ago, parts of the United States experienced an annular solar eclipse and witnessed the Ring of Fire. During today's total solar eclipse, the moon will pass directly between the sun and Earth, temporarily blocking the sun's light and casting a shadow on the globe. That moment is called totality, and the path of the shadow is called the path of totality. The only way to experience a total solar eclipse is to be in this path. When the sun is entirely hidden by the moon, the outer atmosphere of the sun, the corona, will be visible by the naked eye. Anyone outside the path will experience a partial eclipse. People have been observing this spectacular event for millennia. For the past 25 years, we at the Exploratorium have partnered with NASA to send expeditions around the world to broadcast total solar eclipses so many more people can enjoy them as they happen. The Exploratorium is a hands-on science museum in San Francisco, and our founder, Frank Oppenheimer, believed that the world is an understandable place and that people can learn about the world through experiencing natural phenomena. We're proud to have shared so many eclipses around the world, most recently bringing you the annular solar eclipse from Valley of the Gods, Utah. Today, we've sent 2 expeditions to 2 different locations to bring you this total solar eclipse. We have a crew at the planetarium in Torreon, Mexico, who we'll check in with shortly. And we, of course, have a crew here in Junction, Texas. Torreon is going to experience totality first, and just 11 minutes later, we will experience it here in Junction. So even though Torreon is over 500 miles away, it's only going to take 11 minutes for the moon's shadow to move from there to here. Make sure you have your eclipse glasses ready. You're going to need them during the entire eclipse with the exception of the minutes of totality. If you're outside the path of totality, you're going to need to wear these glasses every time you look up at the sun.
That's right. And today, you know, at the Exploratorium, we like to mix culture with our science, and we have a very special treat for you. We are joined by the Texas Tech student group called Mariachi Los Matadores. They are going to bring us in to this amazing broadcast. Let's hear it from Mariachi Los Matadores.
El carretero se va, ya se va para los Reyes. El carretero no va, porque le faltan los bueyes. El carretero se va, ya se va para los Reyes. El carretero no va, porque le faltan los bueyes. Señor carretero, le vengo a avisar, esos animales se le van a ahogar. Unos en la arena, otros en la mar. Señor carretero, le vengo avísenle a los yunteros que la vengan a sacar.
Amazing. Thank you, Mariachi Los Matadores. What a wonderful welcome here. So we are going to take another look at our telescope and see if the clouds are rolling in and we're having moments of sun. And so if I can get maybe the full disk image, we're going to take a look at that dark shadow that you see on the right hand of the screen is the moon. That's the moon covering the sun, and all of those wispies are the clouds moving along. So we have some telescope views, and another way that we're going to look at it is
well, throughout the eclipse, we're going to use the telescopes.
Let's talk about those.
And so the telescope views, we're going to look at 3 different layers of our sun. So first off, we have the photosphere, which is the innermost layer that we're going to be able to image. And those images are using white light filters. So we're just taking the white light from the sun and we're stopping it down by 99.999%. And so that is going to allow us to really see what the photosphere looks like. Anytime you see a white light image, you're looking at the photosphere of the sun. If we look at our telescopes, if it's not too cloudy, we can actually see some of our images, and we have both full disk and close-up. But we also are going to be looking at the the chromosphere, which is the next layer out, and that layer we're going to be using a hydrogen alpha filter. This is because there's a lot of activity in the chromosphere, and a lot of it is from hydrogen, and so we're going to be looking at this specific band of red light, which is why the images look red or orange to you. Now, this one, we also have 2 different views. We'll have a full screen, and what you're seeing here is a close-up, so you can really, really, really see. Oh yeah, there's the full screen right there. You see the sun's passing, or the clouds passing, which also looks pretty cool, honestly. But you see there's a lot of activity happening on the sun right now. And then finally, during the corona, we're actually going to take off all the filters. And this is during totality. We are going to look at the sun's outermost atmosphere. And during this time, you can take off your glasses. We're going to take off the filters. And as soon as it's over, put them right back on, and we're going to put the filters right back on. Now, you can see our telescope guy, Bill, but he's not over there right now. So
we're going to thank Bill and our crew for bringing these amazing telescope images to us. And those of you who don't have a telescope crew with you, you might have Eclipse glasses, and the view of the sun's going to look a little different. So on the left side, you'll see what it might look like in the telescope. This is a different eclipse. And on the right is what it's going to look like through your glasses. When you look through, the field of view of the sun is actually not that large. It's only about half the size of your pinky. So some other ways we're going to take a look is with our sun spotter, which is a much simpler telescope. We're not going to look at that just yet because maybe the clouds are too much. You can also look at projections of the sun through any small hole. And so maybe you're standing under a tree. We have some leaves here, but we also still have some clouds here. So we have an image of what it might look like right now. Again, this was taken at a different eclipse, but you might notice that the gaps in those, the little spots of light between those tree leaves, that's what's the photo, you have the shadow of the tree in the photo. The gaps are crescents because right now the sun is a crescent. That moon is blocking it. There's a little bit, we past first contact, which is a moment that the moon first touches the sun about half an hour ago, and it's going to keep on moving. The moon moves, and it's going to fully block the sun. We're going to reach totality in another half hour. In Torreon, they're going to be using telescopes at the planetarium where they're located. So we're going to learn a little bit more about the planetarium and then check in with our friends in Mexico.
Los 2 observatorios con los que cuenta Planetario tienen equipos muy particulares para observar sistema solar y el Sol. En esta transmisión utilizamos dos tipos de telescopios, uno con luz blanca, que permite ver todo el espectro electromagnético como lo hacen nuestros ojos, y el segundo telescopio con luz filtrada únicamente en la banda de hidrógeno ionizado, que es el componente principal del Sol. Estos telescopios son controlados de manera remota desde la consola de control que está a unos 50 metros de donde nos encontramos. A través de equipo de cómputo, los motores y los sensores del telescopio se posicionan para obtener las mejores imágenes del Sol. Planetarium trabajó por un año para que esos observatorios fueran completamente robóticos, es decir, que fueran operados con la menor cantidad de personas, pero de una manera sumamente precisa para obtener las imágenes que ustedes están viendo en esta transmisión.
Welcome everybody to Torreón, Mexico. We are so excited to be here, coming live from the planetarium in Torreón, Mexico, and we have a very special guest with us today. We have the director of the planetarium, Eduardo Hernandez. And Eduardo, how do you feel right now?
I'm really excited. It's a very big party with friends and astronomers, very much people seeing the eclipse and share with the families. It's really a special moment for me. 33 years ago, when I see my first eclipse, is remember, and really I hope this party touch the soul of the people.
Yeah, this has been such a big project for the planetarium here in Torreón, and so I was wondering if you could tell us a little bit about some of the work that you've been doing.
Yeah, it's 5 years ago we working for this project and teaching from the people to see the sun. It's very difficult, but the people think about the sun is very dangerous. But now the sun is our friend. It's
our friend, yes.
It's our friend, and it's amazing see the dance of the planets. And now the people enjoy the party.
Yes, there's so much celebrating that's happening here already. And we have very little time left, but also, what is your hope for this event and the people of Torreón?
Yes, I hope the kids look the sky.
Yes.
The kids thinking about the work in like a scientist. I don't know, it's a very special moment for me, for all of them.
Thank you so much.
Thank
so
you,
much, Eduardo.
Veronica.
We're so excited. Back to you.
Awesome. Thank you, Veronica and Eduardo. I am joined now by Dr. Angela Desjardins, who's the lead of the nationwide Eclipse ballooning project. Angela, can you tell us a little bit about the project?
Yes, absolutely. The Nationwide Eclipse Ballooning Project is an education project with significant science goals. The project immerses students from across the country in a NASA mission-like adventure to gather data during eclipses.
Amazing.
The main science goal is to understand how the moon's cold, dark shadow that we're experiencing here right now affects Earth's atmosphere. We have two different types of teams, atmospheric science and engineering, and we're going to turn it over to Danny from Salish Kootenai College to tell you a little bit more about how the atmospheric science teams work.
Hey, welcome, Danny.
Oh, thank you. Yes, my name is Danny Johnson from Salish Kootenai College. Our team is coming from Northwest Montana, and we are part of an atmospheric science team for the Nationwide Eclipse Ballooning Project. What we're doing is we're conducting a high-altitude ballooning campaign, and we're using a setup very similar to what the National Weather Service uses, actually. What we're doing differently is we are conducting 30 launches in 30 hours. That is 24 hours before totality and 6 hours afterwards. And the reason why we're doing that is so we can get a better understanding of how the eclipse affects the Earth's atmosphere. That'll lead to a better general understanding of the atmosphere and will help us understand other things such as better understanding of climate change. So if I can, I'd love to give you a tour of our payload setup. Of course, at the top, we have our helium-filled balloon. It's 4 foot in diameter right now, but it'll expand to be 16 feet wide once it reaches altitude. The next part is a parachute, so that way when it does fall back to the Earth, it won't hurt anything. And then the thing with the green balloon right there, that is a derailer. It'll unspool by about 40 feet to keep the radio sound away from the shadow of the balloon. And then, of course, the star of the show is that little white box right there. That is a weather data collecting radio sonde. and it'll capture temperature, humidity, wind, and pressure. And it'll actually send a snapshot to our ground station via radio waves once every second with all these data points. So as the flight ascends, it's going to capture a lot of data. And I think we're ready to lead a countdown for our 1 o'clock launch. So we'll go ahead and launch in 5, 4, 3, 2, 1.
Yeah! Woo! Thank you for taking data, Balloon.
All right, thank you, Angela. And Angela will tell us a bit more about the engineering team.
Yes, wonderful. So we have an amazing shot there from one of the atmospheric science teams. We also have engineering teams. They fly bigger balloons with a bunch of student-built payloads, including live streaming cameras. These cameras show the view from the balloons at the edge of space, where you can see the curvature of the Earth and the blackness of space. Ultimately, this project is an amazing, life-changing experience for all the students involved.
What are you hoping to do with the data that's being collected?
Right, the data, so much data, will be analyzed for years to come. All the data will be available publicly, and our scientists and students will be working on analyzing that and publishing papers and going to conferences to share their work in the next 6 months to a year.
That's incredible, Angela. Thank you so much for being here and sharing a balloon launch with us.
Yes, absolutely. Go Eclipse, clear skies.
Yes, and as those balloons track the shadow of the moon over the Earth, we actually have a way to track that shadow as well. We have a shadow tracker, which is a map of where the shadow of the moon is, and we see it is slowly approaching.
Land yet, but it will pretty soon. You can see even in the shadow tracker how quickly the moon is actually moving across the sun. Now we are joined today by an amazing astronomer, Dr. Liliana Rivera Sandoval. She is an assistant professor at University of Texas, Rio Grande Valley. Welcome to the show.
Thank you so much.
Thank you for being here. So what got you into astronomy?
Well, you know, since I was a kid, I was amazed by the night sky, but also by the images that were in documentaries, you know, especially those from the Hubble Space Telescope. And who would say that now as a professional, you know, I am user of that amazing instrument for my research. But the thing that really blew my mind is the fact that we cannot go to space and take samples from stars because they are too far away, but that we can learn from the universe through light.
Oh, I love it. I love it. And so you said you use the Hubble telescope now?
Yes.
Like the actual
Yes.
Hubble telescope?
Yes.
First of all, that's really cool.
Thank you.
Second of all, what is your research? Like what kind of research do you use the Hubble for?
Yes, so basically what I do, I study the remnants of stars that are, let's say, at the end of the life of a star like the sun, right? There is a star that is like the size of Earth, but with a mass of like the sun more or less, so it's very dense, right? So they are like stellar corpses that are
Stellar
there.
corpses, so dead
Yeah,
stars.
dead stars.
Okay.
And sometimes you have them with another star of that type, so they are in a binary system, they are orbiting each other, right?
Whoa.
And one of them actually gets material from the other. So it's feeding from the other, like if it was like a vampire star, you
Wait,
know?
you have okay, wait. So you have dead stars and you have vampire stars.
Vampire, yeah.
And so the vampire stars are eating from each other.
Yeah, well,
Holy
one
moly.
is eating the other,
Yeah,
actually.
okay,
Yeah,
that's
yeah.
amazing. And so I'm guessing that you actually use this in outreach to teach kids, maybe?
Yeah, well, I have actually a program that is called Ellas y las Estrellas in Spanish, so Female and the Stars. So that program is an educational project that I have to highlight the work of Hispanic women in astronomy. As a Latina, I think that representation is really important, and I organize conferences, I do outreach events, and I hope to, you know, encourage younger generations to go into astronomy, right? So, yeah.
That's
I
amazing.
hope it
Just like
goes.
you who saw an eclipse when you were younger.
Yes.
And now you're an adult and you're going to see one.
Yeah, exactly. I was like very, very young when I experienced the 1991 eclipse in Mexico.
Mm-hmm.
And yeah, so for me, it was like I have some blurry images in my mind, but now as a professional, it's really a privilege to be here and enjoy this amazing event with all of you.
That's amazing. Thank you so much,
Thanks to
Lily.
you.
Now we're going to take a look at, learn more about different kinds of eclipses and what the differences between them are.
From Earth, we can see two types of eclipses. Eclipses of the sun, which are called solar eclipses, and eclipses of the moon, lunar eclipses. These occur when the sun, earth, and moon align in a straight or almost straight configuration. Astronomers call this syzygy. A solar eclipse happens when the moon passes between the sun and Earth and either fully or partially blocks the sun's light. This only happens occasionally because the orbit of the moon is tilted relative to the orbit of the Earth around the sun, so the moon often passes above or below the Earth. At those times, it does not cross the line between the sun and Earth and therefore does not create a solar eclipse. There are three kinds of solar eclipses: total, partial, and annular. A total solar eclipse happens when the moon lines up between the sun and Earth such that it completely blocks the face of the sun. This creates a circular shadow on a small part of the Earth, and today, people located in it will experience a total eclipse. Since the Earth and the moon are constantly moving, this shadow moves too, tracing out a path called the path of totality. A partial eclipse occurs when the moon is not exactly in line with the Earth and sun, and the moon only partially obscures the sun. From our perspective, this looks like the moon has taken a bite out of the sun. Today, everyone in Mexico, the contiguous United States, and Canada will experience a partial eclipse. Only those of us in the path of totality will also get to experience the total solar eclipse. For those in the path, it'll start off as a partial eclipse, move into totality, and then back to a partial eclipse. An annular solar eclipse, which is what we experienced 6 months ago, happens when the moon passes between the sun and Earth, but the moon is a little further away. It turns out that the moon isn't always the same distance from Earth, and when it's further away, it appears smaller than the sun and doesn't completely block it out.
Right, so let's take a look at our telescopes and see where we're at. Okay.
It's a little cloudy here.
It is a little cloudy. Oh, but it's peeking out there.
The clouds are moving in and out, and every so often you really can see the sun.
Yes, and you can see that we're getting closer and closer to totality. And we can sort of already start to see the light changing, like it's getting a little bit darker here. And you know, we as humans like to connect with nature and observe our surroundings. We got a lot of scientists here talking about data. But you know, we're not the only people who take data and interact with our environment. There are also animals, and there are going to be a lot of animal behavior that you can actually observe at home. So wherever you're at, you can pay attention to the sounds that you're hearing right now, and then what are the sounds later during the eclipse. So animals like birds, who are normally active during the day, might go quiet and go hide. And then you have animals who are more active in twilight and during the evening, and those animals might come out. We don't know for sure, but we're going to find out. Here in Texas, we've got armadillos, and we've got bats in Texas. So Texas is home of the largest bat colony on Earth. It's called the Bracken Cave, and we actually have footage of the Bracken Cave. And right now, you see there's not much happening because it's full daytime. But we're going to check back with those little creatures pretty soon. Now, this is put on by BatCon International, which is Bat Conservational International, and then also Explore.org. So I'm very excited about this.
Awesome. So let's check in on other ways we might be able to view and experience this eclipse. We're going to look at the sun spotter, and again, the clouds are coming and going, but Frank, I'm not sure if you can get the image. We can actually see like the sun is a legit crescent right now. And that's amazing. And I had mentioned before that you can use something that has holes for the sun to pass through in order to image the sun. And so, for example, I'm gonna hope for a little burst of sun. I have a colander here that has a bunch of holes, and if we look at the projections, ooh, it's gonna fade in and out, but we see some crescents. So here's an image of the colander that we took yesterday when there was a full sun, and you see the little holes, projected circular suns, because the sun was a complete circle. Right now, we just had a brief flash of, oh, here we go, maybe we can catch it again. Oh my gosh, that's so beautiful. We see some crescents. If you don't have a colander available, just get a hole punch and punch a spot in a card. I have a star-shaped hole right here. You might not see it because it's pretty small, and a hole that I just punched with my pen. And when I hold this up and the clouds move away, maybe we'll see crescents. So there are really easy ways. If you don't even have this, you got hands. So get your hands, and when you put your fingers like this, you actually make little gaps between them. And so They're sort of like rectangular-ish. Oh, but this is great. If I look at my or Desiree's hands, the gaps in between, we have little crescents because right now we have a crescent sun. That's the image of the sun. The other thing the telescopes allow us to do is get a close-up image of the sun and notice some of its features. So we're going to learn a little bit more about what we might observe.
Our brilliant star, the sun, generates a very powerful magnetic field, and that field goes through what is known as a solar cycle, which has a period of about 11 years. Over the course of each solar cycle, the sun transitions from relatively calm to magnetically active and stormy, and then calm again. The quiet periods are referred to as times of solar minimum. When sunspot activity peaks with dozens of sunspots, it's called solar maximum. Right now, the sun is in a very active time of its cycle. It's predicted that this current solar cycle will peak between January and October of this year, 2024. Sunspots are dark areas on the surface of the sun. They're places with lots of magnetic activity, which actually make them cooler in temperature than the areas around them and give them a darker appearance. An average sunspot is about the same size as the planet Earth, and it can last from around 1 day to many weeks. A solar prominence is a giant loop of electrically charged gas called plasma. They can stretch out for thousands of miles while remaining anchored to the sun. They can last for days or even months and can vary in size, but on average, they're about 10 times the size of the planet Earth. Occasionally, there are also explosions that occur on the sun. One type is a solar flare, which is an intense burst of electromagnetic radiation that travels at the speed of light. Another type of explosion on the sun is a coronal mass ejection, or CME, which is a sudden and violent release of energy and plasma from the sun's corona. Both of these phenomena happen when the sun's magnetic fields realign explosively, sending energy out into space, which can impact Earth. You might be wondering how it is that we know so much about the sun and we have access to such stunning images. NASA and other international space agencies monitor the sun 24/7 with a fleet of solar observatories studying everything from the sun's atmosphere to its surface.
Amazing things happening on the sun, and I'm amazed to be joined by Dr. Jadi Collada Vega, who's a project scientist at NOAA. Jadi, welcome to the broadcast.
Thank you. I'm very excited to be here.
The first thing I'm going to do is we're going to take a look at the telescopes, and we're actually going to say hello to Bill Dean, our telescope wrangler. Thanks to Bill, we have these lovely close-up images of the sun, so let's pull up one of them, and we're going to ask Yari what she notices right now on our active sun.
Oh, this is an amazing image. You're actually seeing the moon actually taking a bite, really big bite of the sun. We're actually looking at H alpha here. It's a zoom in. And this is a very interesting filter because it actually allows you to see prominences and filaments. You know, those snake-like things that you see very dark on the surface. And when they actually, this is actually balancing on top of the surface of the sun, and when they erupt, they create amazing coronal mass ejections.
That's incredible. Those snakes are giant ejections of the sun?
Yes, it's just plasma levitating there, and then when it ejects, it creates the CMEs.
How great. Jadi, why is it important for us to study the sun?
Well, in my field, it's very important to study the sun because it's space weather. When we talk about space weather, when we talk about space weather, we're talking about the conditions in space mostly dominated by the sun's activity. So, you know, we talk about the solar flares, coronal mass ejections. When they arrive at Earth, they disrupt the Earth environment. They create communication problems, you know, GPS signal loss. They can cause problems and damage of the instrumentation of satellites. And in the most intense cases, they can cause power grid disruptions.
And how does this relate to your work, what you do?
It's very important because now I work for the NOAA the Space Weather Observations Office. This is an office that is in charge of making sure we have the right operational satellites at the right vantage points so we can conduct space weather to safeguard the nation, the society. And we do this 24/7, 365 days a year.
And so what are some of the ways we predict what space weather is going to be?
We use amazing missions outside in space and telescopes. One of them is a coronagraph, which you actually see now there, the image. It's actually an artificial eclipse.
So you were watching an artificial eclipse?
Exactly. We're watching an artificial eclipse because you have to block the sun to be able to see where the CMEs are actually going and be able to measure them and know the speed and where they're going. However, if you look at the image, the occulter is actually blocking more of the sun than we actually would want to. The sun was that circle, that white circle in the middle. And however, the moon today is going to do an amazing job and do it so amazing that you actually see parts of the corona that you usually don't see using those telescopes in space.
So we're going to be able to use today's real eclipse to help us learn how much the artificial eclipses, like how good our predictions are?
Exactly. We do amazing studies with the eclipses. One of them is they predict the eclipse before it happens. They predict actually the corona, the atmosphere of the sun before it happens. And then they compare the images from today and see how the models are doing. And if they're doing great, they know on the right track.
So
if
cool.
they are not, they actually have the data to improve it.
Thank you so much, Jardy. We're about to reach totality in Mexico, so we're going to see how well the corona predictions went. Let's send it to Mexico.
I don't hear Phoebe. Okay, stand by, okay. Look, it's like almost.
It's getting darker.
It's getting darker.
It's getting darker.
Woo!
Oh my God, okay, we're almost at the diamond ring effect.
Wow.
Okay. We're almost at the diamond ring. We could take diamond ring. There we go. We could take our glasses off. It's beautiful. We can even see it through the clouds.
Torreon, Mexico, and we are experiencing the most beautiful sight to see here with the eclipse. Ron, tell us what you're seeing.
I'm looking at we can see the corona. We can see it through the clouds. To the right of the sun, I can see Venus, the planet Venus. We still have a lot of clouds here, but it's beautiful. The corona is incredibly bright. It's stretching out about the diameter of the sun that I can see here. As we look down, we can see the horizon, and we see a sort of a sunset all the way around us right now. It's just absolutely beautiful.
Wow, this is like beyond what I thought this would be.
The crowd here is going crazy.
The crowd is just completely losing it here. Well, we see some of the birds starting to fly around and just really taking it all in.
I only see Venus. I don't see Jupiter or Mars. Just a beautiful eclipse this time. This is my 6th eclipse, and it's just as good as all the others, even through the clouds.
Even through
it's
the
amazing.
Clouds, wow.
So this will last a little over 4 minutes for us. Woo! And then, if I can quote Paul Doherty, the laws of celestial mechanics will save us once again.
Exactly. Wow. It is beyond what I thought it would be, Ron.
Isn't it incredible?
I don't even have words to describe.
It's actually a little chilly here now.
Yeah,
and it's been very warm all day long.
Wow, okay.
You can hear the crowds behind us.
The crowds going.
We're in the plaza of the planetarium in Torreon.
We have lots of amateur astronomers here. We have astronomical groups. The press is here. The public is here. It's phenomenal. And now we're going to go back to Texas so they can experience it there.
All right, 13 minutes.
Thank you, Veronica and
Holy moly, that is amazing.
Super amazing just to watch on the screen.
I was sitting here holding my mouth so that I didn't scream and like drown you out because that was so fantastic. Look at this. This is amazing to see. Look at how giant the corona is. What
beautiful image
oh my gosh.
Of the corona.
Yeah, this is just too fantastic. And I loved hearing about how cold it was getting. And I think Ron said that he could see Jupiter? Or did he say he could see Venus?
He said he could see Venus. And, you know, we've been taking the temperature here. And we started out the broadcast around the mid-80s. And now it's dipped to below 80 degrees. And so that's not the clouds. I know the clouds are coming and going. But it's actually gotten noticeably cooler here as we see that we have a crescent sun here, too. So maybe it's getting a little sunny right now. Can we check in on the telescopes? Oh my gosh, we're getting close.
Right, we're only
so
11
minutes away from Torreon, so now maybe we're close down to the 10-minute
Yes, we are getting super close. Now, as we mentioned before, Torreon is 11 minutes ahead of us. And so in preparation, I'm going to pull a full pirate, and I'm going to put on a pirate patch because I want my eye to experience the corona in all of its glory. Like, I've never seen such a thing before. This is my first total solar eclipse, and I'm going to put my eye pirate patch on. I'm so excited. So the whole purpose is for me to darken my vision and get myself used to it. It's getting darker here, but I want it to get really dark.
So yeah, our eyes have evolved to transition from daytime through dusk to nighttime over a long period of time, but today that's going to happen in the matter of minutes. So Desiree is preparing one of her eyes to be ready the moment it gets dark here for the corona. We're noticing that like the shadows are getting a little weird, and you can tell that the colors of the lighting around here is already beginning to change, in addition to getting a little cooler. I'm super excited. I'm just going to check in on these pinholes again because really, if you don't have glasses, you're just at home, put up your hands because we can see some crescents in between my fingers.
Oh my gosh.
We can see a crescent right here in the sun spotter. We are getting so close to totality. I'm pretty excited.
I'm extremely excited. I do notice that my shirt is kind of not a strong blue, but it is getting a little brighter. It seems. I'm not 100% sure because I wasn't paying attention.
I think as our eyes adapt, we're going to notice some interesting things. Desiree's preparing one of her eyes especially to be ready for the dimmer amount of light. And you might have noticed certain things happened as we watched the Torreon totality, but let's focus in on what we should pay attention to.
As totality approaches, you will see the diamond ring effect as the last bit of the sun disappears behind the moon. It's a dazzling burst of light that clings to one edge of the moon as the soft glow of the corona emerges from the background sky. Its striking resemblance to a glittering diamond ring is unmistakable. A few seconds later, you can observe a phenomenon called Bailey's beads. This occurs because the surface of the moon is actually not smooth, but it's filled with craters, valleys, and mountains. So, just as the moon is about to completely cover the sun, the gaps in the moon's rugged terrain allow sunlight to pass through in some places, creating what looks to us on Earth like beads of light. During totality, when the sun is completely blocked by the moon, the full glory of the corona is revealed. We normally can't see the corona because the surface of the sun is far too bright to allow a glimpse of its much fainter outermost atmosphere. But during a total solar eclipse, when the moon completely blocks out the light from our star, the corona comes into view. The corona is wispy, white streamers of plasma that radiate out from the surface of our star, the sun. It constantly changes shape and size, and because of that, each eclipse looks different from the others. If you can draw your eyes away from the sun for just a few moments during the eclipse, you'll notice that the sky has become quite dark, as if it's twilight, allowing other stars and planets to become visible. If you look out toward the horizon, it is also possible to see light from outside of the moon's shadow that you're standing in, which looks like a 360-degree sunset.
Welcome back. Let's look at the telescopes again to see where we're at. Because I'm imagining that we're pretty close. Okay, let's look at the tracker. Because it is cloudy. Okay, look at this. We are really, we're out of Mexico. Well, we're almost out of Mexico at the border. Now, joining us, I want to welcome Eric Christian, Dr. Eric Christian. He's a NASA research scientist, senior research scientist, and he also works on the Parker Solar Probe. How's it going, Eric?
Great, thanks Desiree. It's great to be back with the Exploratorium for another eclipse.
Yes, it's great to have you back. Now, you work on the Parker Solar Probe, so let's figure out a little bit more about it.
We're lying 4 million miles from the surface of the sun, 25 times closer than the Earth is. There are some real puzzles about the corona. The corona is much hotter than the surface of the sun. And if you think about simple thermodynamics, when you get further from a fire, you get colder. So why would the atmosphere of the sun, the corona, be hotter than the surface? The other big question is, there's a solar wind that blows out from the sun at 1 million miles per hour in all directions. And that's what you see actually in these streamers of the corona during an eclipse. Those particles get accelerated up to 1 million miles per hour. We've got ideas, but we can't prove it when we're so far away. And so we've actually got to go to the source in order to understand how the solar wind gets accelerated. At closest approach to the sun, we're going to be 25 times closer than the Earth is. That means the sun is going to be 625 times brighter than it is at the Earth. Things get really hot, but we've got this enormous carbon fiber heat shield that sits out in front of our spacecraft. In the first orbit, it'll get down to 10 million miles from the surface of the sun. And then over 6 years, it'll use Venus to actually remove some of its velocity. And every time it passes by Venus every year, it'll get closer and closer. And so it'll work its way in to our closest approach.
All right. Thank you so much for that introduction, Eric. Now, you said closest approach. How close is that closest approach?
So the closest approaches are really going to start December of this year. We're going to do one more swing by Venus to get us in even closer than we are now. And at that point, we'll be getting to within 4 million miles of the surface of the sun.
4 million miles. So you're going to be within the corona of the sun.
Well, we're all in the corona, but yes, we're going to be in the part where the action is actually happening, where the solar wind is being accelerated and where the corona is getting heated.
That's fantastic. And so once you're at closest approach, then what happens?
Well, we're going to stay at closest approach from that point on. We'll continue to orbit about 3 times a year and getting into 4 million miles at perihelion, the closest approach of the orbit, every single orbit. And eventually, though, we're going to run out of fuel.
What happens when you run out of fuel? I'm guessing the heat shield isn't going to work anymore.
So we need fuel to keep the heat shield between the sun and the important part of the spacecraft, like my instrument. So once we lose fuel, we're going to go in sideways and the back part of the spacecraft will melt off.
Oh, no. Okay.
But that's many years away.
Yes. Okay. That's great. So what kind of findings have you gotten from the Parker Solar Probe over these several years?
Well, we're already starting to rewrite the textbooks. But the thing is that we're getting so much data. I mean, if you think of science as trying to solve the puzzles of the universe, we're getting so many puzzle pieces so fast that we haven't figured out where all those pieces go yet, so we can see the picture yet. We're in that process now.
That's amazing. I can't wait for the whole entire puzzle to be solved. Now, I actually, because the Parker Solar Probe is kind of chilling around the sun in the corona, I would like to look at this photo that was taken in 2017. This is a composite image that shows the corona, and I'm wondering, like, what are we looking at? Can you walk us through this picture?
So this is a relatively active sun, and it should be similar to the corona that we see today. What you see are a bunch of helmet streamers. That's where structures start wide at the sun and then narrow down.
Those are the ones that look like troll hair.
Yes,
yeah,
exactly.
Okay.
And then on the top and the bottom, you can see what are called polar plumes. That's where it goes out almost straight from the sun. And that's where the rotational poles of the sun are.
That's fantastic. Thank you so much, Dr. Christian. Thank you for joining us again.
It's always great to be with you.
All right, so now we're going to check in with the solar tracker again because we want to know where we are.
Okay, we see the shadow of the sun is crossing the border into Texas, or has crossed the border into Texas. It's moving pretty quickly. Incredible. Incredible.
This is great.
So Jessica Taylor, who is a principal physical scientist at NASA and part of the GLOBE program, has joined us. Jessica, will you tell us a little bit about GLOBE?
Yeah, so GLOBE is an international education and science program. We're a citizen science program engaging the public in collecting environmental science data about their environment.
So what sorts of data are you taking today?
So I've been collecting temperature and cloud data, and we've had a lot of changing clouds today. Actually, when we got started, we had high cirrus.
Oh, wow.
It transitioned to alto cumulus, and now we've got some pretty big cumulus clouds.
And what are you noticing about the temperature?
Yeah, so the temperature itself has dropped pretty dramatically. We started at 81 degrees Fahrenheit, and now we're down just around 77 degrees Fahrenheit.
Oh my goodness. So you mentioned that this is a citizen science project.
Yes.
Can you tell us more about what that means?
Yeah, so citizen science, another name for that could be participatory science or volunteer science. It's just a way of non-professional scientists getting to be involved in science. And NASA has a number of citizen science programs where the public can participate in NASA's science missions.
And what do you hope the data collected from today will inspire folks to do?
Yeah, well, hopefully this is inspiring everyone to be curious about science. And that's what you can do in citizen science, is actually participate and engage. And today we're collecting all of this temperature data and cloud data. In 2017, we did this, and we were able to publish papers about how cloud data like this, you had not as deep of drop in temperature as to when you had clear skies. So it's just really exciting to know that actual citizen science data can be used for science research.
That is so incredible. Thank you for joining us today,
Yes,
Jessica.
of course.
Thank you for taking all of this data, helping us learn
and
more
I hope
about our world.
People keep joining the GLOBE program, because it's beyond today. It's a year-round program.
Awesome. And so it's pretty cloudy here. Let's take a look at the telescope. You don't see much. I think it's clouded over, and we're so close to totality that there's only going to be a sliver of the sun. So maybe we can take a look at the tracker. Yep, here we go. I see it. It's coming toward us. We are about a minute away from totality here in Junction.
It's getting dark. I'm feeling dark.
It's getting so dark. It is not a problem. It's not just the clouds.
It's not.
the
It's actually
camera. It's
dark.
not your monitor. It is noticeably dark and much cooler here.
Much cooler. I wish I brought a jacket.
Yeah, it is super cloudy here, and so we can't notice any shadows, but I do notice like the colors changing on your shirt. Like the reds are a little dimmer and the blues are a little
like
brighter.
my collar is not even that noticeable anymore.
We hear some activity with folks staring up. The clouds here maybe. Yeah, we're looking
it's
at
getting real dark here. I'm sure you can see us. We are fading out quickly. This is a drone image. Oh my goodness, it's directly above us.
Above Junction, and
it's getting so
oh
dark,
my gosh,
Julie.
you can actually see the shadow coming at us.
Oh my
and it's bright,
gosh.
so it's dark in one direction and bright in the other, and we must be in totality.
Yes, I believe we are in totality
this
now.
is-
Taking off my eye patch.
What do you see?
It's brighter. I can see better, like I can see in the dark with my eye patch, but oh my gosh, like I can see, like it's pink over there, like it's a sunset far off to the, I don't know what direction that is.
For sure, there's one side of this field that's dark.
It looks like dusk
and
on
the
one
other
side
that's bright. So
Look at that
side
drone
is
footage.
outside the
my
field of the
gosh.
shadow.
Yes.
This is incredible.
This is absolutely,
so,
and it's just real dark. Like I don't know, man.
Yeah,
This is
I'm
kinda
not
tripping me
sure.
out.
Even though we can't see the data, any light on the telescope is still capturing whatever light, and I'm wondering if we're able to hear any sonification. The Exploratorium has a sound artist named Wayne Grimm who takes in the light data from our telescope and reinterprets it as sound, creating a musical composition that's really a beautiful blend of art and science. So the sonification allows us to experience Eclipse in another way, and I'm wondering, can we listen to this eclipse at all? The feed has not cut out. We are just watching and listening to totality. I see a spot.
I see a spot.
Look with your pirate eye.
It's gonna clear up in a second. This is gonna come past. This is crazy. This is not okay. What the fuck, Charlie?
So I think we are, by our timer, maybe 30 seconds away from totality. And Desiree was even mentioning, like, this is going to clear up, and now we can actually see the light coming from behind us.
Yes.
Because the shadow's moving this way across the field.
I'm having a very, strong emotional reaction to this.
It's pretty.
Because it's not
beautiful.
normal,
You don't see
but
the
it's
sun
gorgeous.
come at you ever. But there it is. You can maybe see it starting to get lighter behind us. That's actually the shadow of the moon moving out of the way. And because of the clouds, we can't see the sun or totality, but we know the moon's moving because the light's coming.
It sure is.
It's pretty amazing.
I'm actually going to go and maybe check out what other people are experiencing.
I think a lot of people are experiencing their first total solar eclipse today, and we're super curious what they thought. You might have heard them in the background. Maybe we can take a look at the drone footage to see what the landscape looks like from way up there. It's pretty dim here. Oh my gosh, it's totally, you can see the light. It's like in real time.
It has moved.
It's all of a sudden brighter. Hey, Desiree, how are folks feeling over there?
So over here, I've got some young lady warriors. These are children from the Talkington School of Young Women Leaders. Where are they? They're over here. How is this eclipse for you all?
It was scary.
Right? What was scary about it?
Like, it started turning black. It was like it was 7 p.m.
That's exactly what I said. Did you feel a little bit colder?
Yeah, and like it was crazy. I felt colder, and like my eyes started getting bigger. We noticed that like immediately.
Oh, you mean like your pupils started dilating because it's getting dark? Oh my gosh, I didn't even think of that. And how about you? What is this like for you?
It's just crazy because at one point when the sun, like when you could still see a little bit of it, like the green got lighter, and then when you'd look at red stuff and it would just be like completely darker.
Yes, I noticed that on my shirt too because my shirt has all the colors on it. Julie.
The speed at which it is lightening and brightening here is pretty remarkable. I'm wondering if we can check in on those bats at Bracken Cave to see if anything is going on there. Oh, we actually see some bats! We can see some bats. So they aren't bothered by the clouds. The temperature change and the lighting change was enough to have some activity there, which is pretty phenomenal. Let's take a look at our shadow tracker because we are now past totality here, and indeed we see that the shadow of the moon has moved on. We saw it with our eyes, we saw it in real time. This is pretty incredible, and the weather's going to do what it's going to do. We can actually see the sun peeking through the clouds here, and the thing about weather predictions is we don't really know much about what happens when the solar radiation gets cut out so abruptly. Desiree, I think maybe you're with some Eclipse ambassadors?
Yes, we have Eclipse ambassadors from the NASA Eclipse Ambassador Program. How are y'all today?
Good, this is awesome.
Yeah, this is the best. This is so cool.
Is this your first eclipse?
Yeah.
Haha, excellent. Mine too. Yeah. So what happened for you? Like, what did it bring up for you? How was this experience?
It was just incredible. Like the fact that it's 1:30 and it was as dark as it is at like 7 p.m. now, it's crazy.
Yeah, just feeling it like get darker and darker and darker. Like I didn't know when it was gonna stop. It just kept going, and all the clouds. It got so cold. Like that was incredible. Like I'm speechless. Honestly, I don't know what to say.
And so, how about the NASA Eclipse Ambassador Program? What can you tell us about that?
Yeah, so the Eclipse Ambassador Program, it's NASA partnered with the Astronomical Society of the Pacific, and basically what they've done is we've gotten a bunch of ambassadors all across the world. There's about 700, and we had to put on community outreach programs just to inform our communities about the eclipse.
That's amazing. Thank you both so much for being here and for doing the amazing work that you do.
Yeah, thank you.
All right, back to Julie.
That's great. The light is coming back and it's warming here. And as you return to the familiar of your day, I hope you take this event as a chance to reflect on our shared humanity. You know, humans have been using our observations of the skies to deepen our understanding of the world for millennia. And a number of our cultural traditions are based around the movements of the moon. So if you're someone who celebrated Easter last week, that's always timed to be after a full moon. And if you're observing Eid tomorrow, you know there's a new moon coming. I know there's a new moon tonight because I just saw it block out the sun. And, you know, eclipses really offer a particular perspective on our shared presence on Earth. And there's a lot of suffering in the world, but we are all living on this dot together. And we hope that we can all lean into our compassion and our shared humanity and presence on this planet. Thank you for joining us.
eso vivo esperando.
Amazing. Thank you.
Yes, thank you
Los
so
Matadores. We are actually taking a look at the replay of Totality from Torreon because they just had such a beautiful moment. You might have seen that diamond ring flash.
Look at those prominences coming off of the sun. You can see around at the top and the bottom. So this is actually the chromosphere that we were able to see. And oh my gosh.
And
look
you know, when you
that.
look at the corona, it's about the brightness of a full moon, but the size of it, like it's actually multiple moons wide, because if you think the moon takes up the same amount of space in the sky as the sun, that's why we have eclipses. But the corona projects far beyond that. So even though the lighting is like the full moon, you get this beautiful spread of light across the sky.
And it looks, I can see some helmet streamers actually on the top left around like 10 o'clock or so. Do you see that? Those are what Eric Christian was describing to us. So like they start off long and then they get, or fat, and then they get really skinny. And then you can also see the polar plumes at the north and south pole of the sun.
Yeah, that
wow,
was
these are fantastic.
Truly magnificent. I'm so glad they had the clear skies in Torreon and that we were actually able to experience the eclipse with them. From all of us at the Exploratorium, we thank you so much for joining us, and we encourage you to keep continuing to pursue your curiosity about the world, yourself, and each other.
Yes, bye.